Okay, so we are going to dive in to the RAA pathway. This is not an extremely complicated pathway. Once you understand and kind of can put it all together, you're going to be fine. So this won't take long. We'll just go right into it. Well, the first thing that we need to figure out is what is the goal for the RAA pathway? For one of the goals is to regulate the body fluid, which body fluid's main component is water. So water regulation. Also, it is a regulator of our blood pressure, and it has the ability to regulate the sodium levels in our blood plasma. So overall, it's all homeostasis. We're just working towards getting that balance back to our body, mainly through our fluid and solute balances. So the first thing that we need to talk about is what all makes up this system. So RAA stands for renin, angiotensin, and aldosterone. Aldosterone is a hormone, whereas these two are more enzymes, and they all come from different places. Well, renin is going to come from the juxtaglomerular cells of the nephron. Angiotensinogen comes from the liver, and angiotensinogen is the inactive form, but we'll talk about that in a second. And aldosterone, the hormone, comes from the adrenal glands, which, if you can remember that, we kind of reviewed all of this and learned about it in the endocrine system, but we're just going to refresh ourselves. So here's a little diagram that shows you kind of the pathway of what what all has to happen. The main goal is to get this aldosterone here, but angiotensin 2 is also a big key player in this as well. So the first thing that has to happen is renin has to be stimulated. We have to get that renin to be released so that we can start this chain reaction. So things that can stimulate renin is a drop in blood volume, which if you're dropping the blood volume, that means that we don't have, we're losing the content of our blood. So like blood fluids, right? Which is going to drop our blood pressure. We don't have as much blood flowing through our blood vessels, so the pressure is going to drop. Also, it can be stimulated by a drop in our sodium levels in blood plasma, which all three of these things kind of go hand in hand together. So once one of these things happen, or when this all happens, I should say, the kidneys, they go ahead and kick on renin, start renin, so that renin can begin to activate our little pathway here. So when renin gets released, it is going to go over to the lungs to stimulate the release of angiotensinogen. When it does this, renin converts angiotensinogen to angiotensin 1. Now, angiotensin 1 is still an inactive form. It can't do anything. It still needs to be converted as well. How angiotensin 1 gets converted is by the angiotensin converting enzyme, ACE, that's found in the lungs. So angiotensin 1 goes over to the lungs, uses the enzyme ACE to turn into angiotensin 2. And when that happens, we start to see everything kind of trigger up and everything starts moving along. Angiotensinogen Angiotensin 2, he's a power guy. He does a lot for this little system, but he stimulates the release of aldosterone. Okay? So let's see here. Okay. So angiotensin 2. So this guy, he's going to target blood vessels and he targets the kidneys. When he's targeting blood vessels, he's targeting veins and he's targeting arteries. The targeting of the arteries is going to increase our total peripheral resistance, which he does this by it's a vasoconstrictor. So he's going to constrict the walls of our blood vessels to make them narrower so that we can increase our blood pressure. In the veins, when he constricts the veins, that's going to increase venous return. When we increase venous return, we increase blood pressure as a result. Now, he also targets the kidneys, and there's two ways that he targets the kidneys. But one more thing that I forgot to add about the blood vessels: when the blood vessels are targeted and angiotensin 2 is exerting its vasoconstriction, this happens in minutes. Like it's a very quick reaction, and it can get our blood pressure back to where it needs to be to achieve that homeostasis in a short amount of time. The kidneys, however, when angiotensin 2 targets the kidneys, it's a little bit longer of a reaction. It takes like a couple days to happen, but it still helps. So just know that this one's faster and the kidneys are a little bit slower. So to target the kidneys, angiotensin 2 first goes over to the afferent arteriole here and constricts it. So he makes it narrow. When this happens, he's kind of slowing the blood supply that's going into the glomerulus here. And what that does is it decreases our glomerular filtration rate. So we decrease our filtration rate. And also, by doing this, we're retaining more water and everything that we need to get our blood pressure to go back up, right? Another thing that he's going to do is he's going to target the adrenal glands so that aldosterone can be released. Now, aldosterone targets two areas. He targets the distal convoluted tubule, okay, and then also the collecting duct. The reason that aldosterone is targeting these two areas is because the goal here is to increase sodium reabsorption. Two places that sodium gets reabsorbed in the nephron is the distal convoluted tubule and the collecting duct. So when we're increasing sodium, that means that we're increasing our blood volume, and we're also bringing our blood pressure back up and bringing back the homeostasis that we're trying to achieve. Now, aldosterone works kind of hand in hand with the antidiuretic hormone, which we'll talk about in another video. But when we're increasing the amount of sodium that we're reabsorbing, remember that water follows solutes. It wants to go through osmosis. It wants to go wherever the solutes is going. So if we're bringing in more sodium, we're reabsorbing more sodium, more water is going to follow. And the goal of a antidiuretic hormone is to increase our water reabsorption. So this could be like if we're dehydrated, or if we need to bring back up our blood pressure, and just things of that nature. So that is the whole system of the RAA pathway. And I hope that now you have a better understanding. If you need to, go back and watch the video and pause it on this diagram so that you can kind of make your little notes or whatever you need to do. Thanks.